Okay.
Okay, starting?
Yeah.
Chapter 1, managerial. The definition of managerial economics is using scarce resources to achieve managerial goals. There are two types of profit that we have to know and be able to differentiate between. Accounting profit focuses on explicit costs, and that is total revenue minus the dollar cost of producing goods and services, whereas economic profit is total revenue minus total costs, and total costs include opportunity cost, which are the costs of the next best alternative that we gave up to choose one good. There are incentives and for managers to change the allocation of the input of resources, and that is namely the change in profits. Changing the combination of inputs that you use changes the profits, and that is an incentive for us to understand managerial economics. So in markets, there are buyers and sellers. Trade relationships are predicated on, or bargaining power is limited by three types of rivalry. Consumer-producer rivalry, which is rivalry on prices. Essentially, this means that consumers want to consume at lower prices, but producers want to sell their goods to the producers at the highest possible price. And so that is consumer-producer rivalry. Consumer-consumer rivalry is the idea of limited supply. So there's a limited number of available supply in the market, and there's a limited number of actually like high quality goods. So consumers are competing with each other to get the lowest priced, highest quality goods from suppliers. And then the last type is producer-producer rivalry, which is the idea that there is limited demand. And so producers are fighting to capture the biggest share of consumers' like value that they possibly can, the biggest share of the market demand. Time value of money is essentially the idea of the gap between when costs are borne and when benefits are actually received. So present value is the mathematical interpretation of this timing gap and the cost of that. So present value of one future value is essentially the idea that, okay, if I have a certain amount of money and I want to invest it at a certain rate for an amount of time with this interest rate, what is the outcome? Like, what am I going to get? So present value equals future value over 1 plus the interest rate to the power of the number of years. Present value also equals future value minus the opportunity cost of waiting. Multiple streams of present value, it's notated like with a sigma. So all that means is that you take all of the present values for the various streams of investments that you're going into, and then you do the individual present value calculations, and then at the end you sum them all up. And so that's multiple streams of present value. Net present value is present value minus the current cost. We want a positive net present value. There's three graphs essentially that talk about max profit maximization, which is the max current and future profits. For the first graph, it is the difference between the benefits and costs, and so you want the largest difference where the benefits are on top, obviously. For this one, this is total revenue. It looks like a big bell curve, and so you're trying to produce at the top of the bell curve, which is max revenue. And then here, it is when marginal benefits equal marginal costs. So it's like this, marginal costs, marginal benefits. Where they intersect is where we're trying to, that's like max benefits. So marginal analysis tells us that Q is the marginal control variable. That's the idea that managers can control the amount of inputs that we're consuming. So benefits is BQ, costs is CQ. And the objective is to maximize net benefit, which is benefits at a quantity minus costs at a quantity. So that's net benefit at a quantity. Marginal principle is the idea that marginal net benefit, the max marginal net benefit, is equal to marginal benefit where it intersects with marginal cost. So that's the graph that I just did right there. So when marginal net benefit is 0, there is no further benefit from adding one additional unit. That's what marginal means. It's the idea of adding one more unit. So chapter 2 talks about supply and demand, essentially. So you have the market demand curve. That is the definition of that. The technical definition is the price and quantity that consumers are willing and able to purchase, holding all other variables constant. The law of demand is the idea that there's an inverse relationship between the quantity demanded and the price. So as quantity demanded increases, price decreases, or more accurately, if price increases, then quantity demanded will decrease. The exception to this are Veblen and Giffen goods. Veblen is essentially the idea that, oh, it's a luxury good, and so the rich people, they aren't really affected by changes in price. If it's a luxury good, then they can afford to do it, and so it's relatively inelastic. Giffen goods is an essential good. Think like an EpiPen would be an essential good, and so you really couldn't give that up even if the price of EpiPens increased. So the exception to the law of demand are Veblen and Giffen goods. A change in price is a move along the curve. You can kind of remember this because the classic curve looks like, or the classic graph looks like this. Price is over here, quantity is over here. So it's a sliding scale. If price changes, you already have an entire axis dedicated directly to price. So you simply look at demand, which relates to consumers, and then you move along that curve depending on what happens to the price. If it's an increase or a decrease in price, you simply move along the demand curve, which relates to consumers. Other things, if it's not a change in price, then it is a shifter. So the entire demand curve will shift up or down. So these shifters are income, and this is normal or inferior goods, related goods prices, so this is substitutes or complements, ads and consumer taste, and then this is divided into informative and persuasive ads. A population increase or a population change in any way does change the demand. Consumer expectations also shift demand. So a linear demand function, can you zoom into this? Because goodness gracious, yeah. This is essentially the quantity of X that is demanded. The number of goods that are demanded is equal to alpha O plus alpha X PX. PX talks about good X. Alpha X is always negative because of the law of demand, plus alpha Y PY. This is, if you look over here, it's QXD. That's the number of goods demanded for X. And then this is Y, which means that it's a different good. Y is not X. And so you're looking at related goods. So if it's positive, then it is a substitute. And if it's negative, then it's a complement. So alpha Y, alpha X, alpha M, alpha H, those are always going to be provided for you. And so you don't need to worry about that. It's going to be something like 5px plus 8py, something like that. And then if the value is positive for the substitute good, then it is, or for this one, then it's a substitute good. If it's negative, then it's a complementary good. Same thing for M. You know that M relates to income. And so if it's a positive alpha M value, that means that it's a normal good. If it's a negative alpha M value, that means that it is an inferior good. Alpha HH is simply any other shifters that potentially could arise in the problem. So an inverse demand function is when you plug in all of these values and then it's used to make a market demand curve. So you plug in all of the values from this and then you simplify it. You generally don't get the px. So then you solve for px and then you solve for px in terms of qdx or qxd. So you move qxd over, you move px over, and then you solve, simplify, and the new equation is the slope of the market demand curve. So consumer surplus is the idea of value pricing and price discrimination rely on consumer surplus. So you have to know how to calculate it and essentially what it is. Consumer surplus is technically defined as the value that consumers get from goods and services, but they don't have to pay for it. So total expenditure is the price per unit times the quantity consumed. Total consumer value is the sum of the max amount consumers pay at different quantities. And so graphically this ends up looking something like this, where the difference between the top part, this top triangle right here, is the consumer surplus, and then the bottom square is the total expenditures, and then the line is the total consumer value. Yeah. So supply has its own unique shifters and equations. So a change in price is a movement along the quantity supplied, or a change in quantity supplied, which means that you move along the curve. So this is the supply curve, and then you just move along the curve depending on what happens. If anything else happens, then that's a shift in the curve itself. So things that could do that is prices of related goods, technology, increase or change, government regulation, the number of firms, taxes, which are subdivided into excise and ad valorem taxes. Ad valorem is a percentage tax, excise is a flat rate tax. and consumer expectations. So if there's an expectation of recession, then you will have excess supply, stuff like that. And then for the taxes, the types, the two ones, excise, it ends up looking like this, where the graph just shifts, and if it's ad valorem or percentage, then it goes like this. It rotates on an axis. The linear supply function is the quantity of X that is supplied is equal to beta 0 plus Bx Px. This, for context, it says plus because all of them are just, in the base formula, it's always plus. But this is always going to be negative because of the law of supply. And so then it's plus beta WW, and this is always negative, or this is if this is negative, then it means that we're increasing input prices. If it's positive, that means we're decreasing input prices. And then it's plus BRPR, which is related goods. So this essentially tells us if it's a substitute or not. So if it is positive, then the price of the related good increases, the marginal rate of substitution shifts to related good and away from X. And then beta HH is simply anything else that the equation could potentially throw at us, we plug into there. However, again, all of these beta values are provided, and so all you have to do is plug, and then you do the same steps. If you want to find, is there an inverse supply function? No. Okay. Yes. Okay. Same steps for inverse supply function, and then you solve for Px, and I see I put it here, and then that would be producer surplus right above there. You always remember that consumer surplus is below demand, producer surplus is below supply, up to the quantity or the price. And then you have price floors and price ceilings. Price floors, to be effective, they have to be above equilibrium. Price ceilings, they have to be below equilibrium. So essentially, this is the idea that if you have equilibrium, and then the government imposes a price floor that is $3 more for than what it used to be at like 5. So now it's 8. And essentially, you look at this numerical value, and you follow it out. So start at price, go to demand, and then go down. That's your new quantity demanded. And then if you go to supply, where supply and the price floor intersect, and you go down to the quantity, that's the quantity supplied. The fact that there's a difference between the two tells us that there's a surplus. And so given the quantity demanded and the quantity supplied, price floor is going to be your price, and then you're going to have an equation for PD or QD and QS. You simply plug the price floor back into that, into C, into P, solve for units, and then subtract the value of QD and QS from each other to get the amount of surplus. It's the same idea if you have a price ceiling, except now it's surplus, because if you follow demand, it has like a higher demand, but you have a lower supply because have such a short, the low price in the market, which means that it's not profitable for consumers, or it's not profitable for producers to make it, but it's very good if consumers can get it because the price is artificially lowered. So it's the same idea where you would solve for QD, QS by plugging PC in, then solving for units and subtracting to get the surplus value. And if they ask you to find the price for the 5th unit, you know that 5th unit relates to quantity, so you plug 5 into the quantity demanded and then solve for P. Yes, and then another thing that I have to note while I'm here is that the entire area, shaded area below the curve for surplus, is the cost to the government of purchasing the excess. So you do the same steps, you find the surplus, and then you multiply it by the price of the price floor. So you would say if that's like a price floor of 3.5, the surplus is 5, you would just multiply those by each other, and then that would be the cost to the government of purchasing the excess. So besides that, all you have to know is basic supply and demand shifters and what that actually looks like. So easy, supply increases this way, decreases this way, demand increases this way. Wait, no, okay, yeah, this way and this way. Oh my gosh, it's weird with my hands. Okay, Chapter 3, elasticity, measures the relationship between two goods. We're notating those as G and S. So G and S are goods. So the elasticity for goods G and S is equal to the percentage change in G over the percentage change in S. If there is a functional relationship G equals F of X, or F of S, then we know that the elasticity for G and S is equal to the derivative of G over the derivative of S times S over G. We don't really need to know this because this is like a course that doesn't have calculus in it, but that is an equation that is given to us, so we just know that. And so once we calculate elasticity by finding the percent change in G over the percent change in S, if you were given a table, I'm just going to back up one step and explain how to find that. So if you're given a table, then it's essentially the new value minus the initial over the initial divided by the price. Is that right? Divided by the new value over the minus the initial value divided by the initial. So you find those two values, and then that's the percentage change. Anyways, once you get that value, if it's over 1, then G is highly responsive to changes in S. And then if it's less than 1, then G is only slightly responsive to changes in S. There's two types of elasticity. There's point elasticity, so this would be like at point PQ, or there's arc elasticity, which is a range of values, and you could typically calculate this with midpoint. Point elasticity is typically used for small changes. It requires calculus, and it's different depending on the direction, whereas arc is consistent and usually consistent but going both directions, and then it's for larger changes, and the math is a little bit simpler because it's midpoint calculations. So own price elasticity of demand. Elasticity is very pretty with its formulas, so it tells you the formula right here. So this says, is essentially what own price elasticity of demand is the responsiveness in a percentage change in the quantity demanded of X to a percent change in the price. So what is the relationship between a change in price and the amount of X that I demand as a consumer? How elastic, how important is this good to me? How essential is it, essentially? So this is the elasticity of the quantity of X that is demanded and the price of X. All of that is a subscript of E. And so that's equal to the percent change in the quantity of X that is demanded over the percent change of P of X. So if you notice, you can simply take this part and put it on the numerator, and then take the second part, P of X, and put it on the denominator. And then for interpretation of this, the sign is going to be negative by the law of demand. However, with elasticity, when interpreting, we look at the absolute value, so the distance from 0 on a number line. If it's over 1, then it is elastic. If it's less than 1, it's inelastic. If it's exactly 1, then it's unitary elastic. Graphically, this ends up looking something like this, where if you have this is unitary elastic, this is inelastic, below is inelastic, above is elastic. When you have price and quantity on a graph. And then you can actually follow that down, and now if you put total revenue on the y-axis and then you have quantity on the x-axis, you look at the bell curve and you notice that at the top you have max total revenue, and that happens to be, or it doesn't happen to be, it is where you have unitary elasticity at exactly the value of 1. So if you have elasticity at 1, that is where you have max total revenue. You also have the total revenue test. So you can tell that it is elastic when total revenue increases when you decrease the price. It is inelastic when total revenue increases when you increase the price. Logically, this follows, because if you have an inelastic good that you cannot give up no matter what, and the price increases, say insulin, you're always going to need insulin if you are require it for medical reasons, right? And so even if they increase the price of insulin, you're still going to have to purchase it because it's essential for you to continue living your life. Which means that it's an inelastic good. Total revenue for the company increases when they increase the price. Yes. Another thing is that elasticity varies along the inverse linear demand curve. So that's over here. If you look at the individual calculations and change it, then it varies. It doesn't exactly stay the same. So elasticity does change. So factors affecting one own price elasticity. There's three of them. So it's the availability and the number of substitutes in the market. It's the time and duration and the purchase horizon, which is essentially like, okay, how long does it take to acquire this good and how far out am I planning on getting this? And then it's also the expenditure share of the consumer's budgets. So there's other types of elasticity, and again, it's the same thing where this was very pretty. Own price elasticity of demand told us exactly right here what the formula was. It's the same for the other types of elasticity. So now we're looking at cross price elasticity, which is a percent change in demand of X when there's a percent change. I believe it is price, but I forgot to put the P there. Anyways, so no, it's Y, of Y, percent change of Y. This would have been said of Y, because it's cross price elasticity, so we're comparing two goods. And now we have goods X and good Y. So elasticity of the quantity of X that is demanded and PY is equal to the percent change of QXD over the percent change PY. And then it's, again, it tells you. So you take the first part, put it in the numerator, you take the second part, put it in the denominator, you know that it's percentage change, and you know that this is the initial, or the new minus initial over initial to do the actual calculations for the percent change for either of those. And then you simply plug and chug, solve it. And then if the outcome is positive, then they are substitutes. However, if it's negative, then they are complements. And then we have a nice, beautiful equation for what a change in revenue for one good when a firm sells two goods. So that is a change in revenue is equal to the revenue for X, parentheses 1 plus the elasticity of X, and that entire thing is a subscript, plus the revenue from Y and the elasticity of X times the price of X, and then multiply that entire value once you get it by the percent change for the price of X. Yeah, so all of those values are going to be provided, and so all you have to do is like plug them in and then solve. Income elasticity is, again, it tells you in the formula, it's the percent change in demand for a good when you have a percent change in income. Say income increases 10%, what happens to the elasticity of the good? And what does this tell us about it? So elasticity of quantity X that is demanded and income is equal to the percent change in the quantity of X that is demanded over the percent change in income. M is the notation for income. If it's positive, then it's normal. If it's negative, then it is inferior. And then if you are given the limit, the linear demand function, then you can find E from any of these, like from just taking the values. Because if you notice, it all exists right here. So you have own price elasticity, cross price elasticity, and income elasticity. All of those values that you need are right there in the linear demand function. And yeah, that's pretty much chapter 3. Chapter 4 talks about individual behavior. And so this introduces the idea of indifference curves. Simply, that is the idea that along an indifference curve, which ends up looking something like this, like that, consumers don't care what they are producing, what they are consuming. So consumer opportunity bundle is what they can afford to consume, everything that they can possibly afford to consume. However, consumer preferences are what they will actually consume. We want to maximize utility, and so utility is essential. Max utility is where we consume on the farthest possible indifference curves. So maximizing utility is consuming on the indifference curve that is farthest from the origin, assuming that they radiate infinitely outward. And then some properties of individual behavior are completeness, monotonicity, diminishing marginal rate of substitution, and transitivity. All that means is that you have A can be preferred to C, B can be preferred to C. Monotonicity is the idea that more is better. So if you have two bundles and one of them gives you much more attractive, like it just has more things for a lower price, that's monotonicity. Rational consumer is always going to want to consume the larger amount that they can have. for the lower price. Or the same price. Diminishing marginal rate of substitution simply means that if there's a diminishing return on value for every additional unit that you substitute. So that explains why our curves are curvy and not straight. And then transitivity is simply if A is preferred to B, and B is preferred to C, then A is preferred to C. If A is indifferent to B and B is indifferent to C, then A is indifferent to C. And then the notation, put it over here. The notation for preferred looks like this, and then the notation for indifferent looks like that. So it would be something like B is preferred to C, or B is indifferent to C. That's what that looks like. And then you have indifference curves, budget constraints. So budget set is what is affordable. That's price of X plus PY. Y has to be less than or equal to the total income that someone has. That's everything under that is affordable. So that's a budget set. Everything that you can consume. You can consume less than your income. You don't have to completely exhaust it. That's within your budget set. So it's the entire shaded part of the graph. And then if you have the budget line, then it completely exhausts your income. We look at this as economists because it doesn't actually change anything. It doesn't significantly change your values. And it complicates it a lot if we add in like, oh, okay, well, we're not going to consume all of our budget. We'll like save some, put some in savings. This doesn't realistically change the outcome of like what we're looking at for interpretation purposes. So for simplicity's sake and not having to do a whole bunch of complicated math with various factors, we say that it completely exhausts the income. So that's PXX plus PYY is equal to M. And so that's the line. So that would be the slope. Marginal rate of substitution is MRS equals the price of X over the price of Y. This is max utility and this is consumer equilibrium. The substitution effect is a move along the indifference curve, and then the income effect is you shift the indifference curve completely, which means that if you have more income, then that is something that shifts the curve. And so assuming that indifference curves exist invisibly on every graph and they expand ever increasing outward from the origin, then you can move along the indifference curve if your income expands. And so you can move to a higher indifference curve, which is something that we want as consumers because we're always searching to maximize our utility. So that's the income effect versus the substitution effect. Logically, if you think back to it, a substitution effect makes sense because you're substituting good X and Y. So you're just moving along the different amounts of good X and Y that you're consuming because you give up one good, like some of good X, and then you consume more of good Y, or you do vice versa, but you're moving along the curve. That's a substitution effect. So chapter 5 is production processes and costs. The production function is the max output given the inputs. In the short run, we assume that all inputs are fixed. In the long run, we assume that all inputs are completely variable. So the production function is equal to Q equals F, and then K and L. K stands for capital and L stands for labor. These are inputs. These are something that, if we think back to chapter 1, we can control as the manager. Like this is something that we can control. These are inputs. And so total product is max output. Average product is output over unit input. And so average product of labor is equal to the quantity over L. Just take the L, move it to the denominator, and know that it's quantity over L. Average product of capital is the same thing. You take this it tells you what it wants you to do with the formula in the question, like in the first part. So average product of capital is quantity over capital. Marginal product of labor, you know that it's marginal, so it's asking for a change. So that's the change in Q over the change in L. Product of labor, if you go back to the basic one, it's like Q over L, and then this is marginal product, so now it's change in Q over change in L. Same thing with marginal product of capital, change in Q over change in capital. So The idea is that managers should maximize their value. In the short run, this means looking at value calculations. So value of marginal product of labor is equal to the wage. Labor and wage are related concepts. And then because you pay laborers a wage. And value of marginal product of capital is related to the rental rate of capital. That's R. And this makes sense because capital and rental rate of capital, like those are related concepts. And so that is equal to the value of the marginal product of labor is equal to the price of X, the price times the marginal product of labor. And so we remember how to calculate that. Essentially, what we can look at this as is value of marginal product of labor is equal to price times the change in quantity over the change in labor, or the MPL. So those are the same thing. Value of marginal product of capital is equal to price times the marginal product of capital, which we remember is the change in quantity over the change in capital. So it all builds on itself. And then we have the idea of diminishing returns. So profit maximization is where there's an intersection between marginal benefits and marginal costs, when marginal benefits equal marginal costs. And diminishing returns is the idea that there is a max amount of labor, like a max efficiency of labor. And essentially, when we're looking at increasing, decreasing, and negative returns to scale, we look at marginal product. That's the MP line. And so we, when it's from 0 to like the max of the marginal product, that is increasing. However, when marginal product starts decreasing, then that's decreasing, but that doesn't mean that it's not profitable to add or beneficial to add one additional unit of labor. When it is negative, then it is no longer profitable to add. So that's negative returns to scale, decreasing returns to scale, and increasing returns to scale. And again, we look at marginal product, which is the one that is like on the bottom. And the logic behind this graph is that, take a restaurant, for example. You have one person running this restaurant. They're completely frazzled, they're stressed, and so you add an additional like one person, and now you've completely doubled your capacity. You can afford to like have someone manning the register, you can have someone cooking food in the back. You have and then you add an additional person and you're like, oh, thank God, there's additional labor to help me out. But eventually, as you continue adding that third and fourth and fifth and sixth person, you only have a limited amount of physical space in your restaurant. And so as you continue adding these people into the restaurant, you start like running into each other, stepping on each other's toes, taking some of the workload. And so you have more people milling around. It doesn't mean that it's not good to like add an additional unit of labor, because you can further subdivide the responsibilities. But at some point, it's decreasing returns to scale. And so that's about where marginal benefit of adding one more unit, one more laborer into the marketplace is decreasing. And then at negative, you assume like, oh my God, there's 50 people running around in this tiny kitchen. Like the kitchen is this big. We're jam-packed. We're sardines in a can. It's actively hindering me to add an additional person, an additional unit of labor. So that's the logic behind that graph. Linear is, this is simply how it's notated. So the quantity is equal to KL, just put them in parentheses, and that's alpha K plus beta L. Leontief is fixed proportions. So you have fixed proportions of K and L, and so that has a slightly different notation. Cobb-Douglas is the idea that there is substitutability for K and L. Again, that's capital and labor. So now you can substitute capital and labor with each other. And so this is the quantity is like K to the power of alpha, labor to the power of beta. And then marginal product of capital is, this is essentially a partial derivative or a power rule, but we've simplified it a little bit. So it's the capital, and then it's whatever the power is, minus 1, and then labor to the power of b, which stays the same. And then you simply like have that. And then it's AK, so you take A and then you put it in front right here. And then you subtract from the subscript 1. Same with marginal product of labor, it's BK, And then now you see how it's like marginal product of labor that you're looking for. So now you're manipulating the coefficient for labor. So it's, you take the is that coefficient? No, it's a exponent. Exponent. You're manipulating the exponent for labor, and so it's the exponent minus 1, and then you take that value, put it in front, multiply it by k, which maintains its same exponent, and so that would become a coefficient, and you'd subtract 1 from that. Yeah, it's essentially a partial derivative where you hold one value constant. And then, yeah, isoquant is the idea that there is a trade-off between inputs with some output in the long run. So it's the trade-off between inputs. Marginal rate of technical substitution, MTRS, is the rate that a producer can substitute between capital and labor with some amount of output. It is the absolute value of the slope of the isoquant, which looks like this. Marginal rate of technical substitution is equal to the marginal product of labor over the marginal product of capital. An isocost is similar to an isoquant, but a little bit different. You remember that you're looking at costs. It says isocost. So it's the combinations of capital and labor that have the same cost, whereas isoquants was the same output. Now you're looking at combinations that have the same cost. So that's the wage of labor times or plus the rental rate of capital is equal to the cost. So you have to have some amount of like, yeah. And then you can rearrange this to be in slope-intercept form and then put it as the slope of this graph. So that's k is equal to c over r minus w over rl. And then that becomes the slope. And so isocosts, they're very similar to indifference curves in terms of what they look like, but you have to remember, first off, they're linear, so I guess they're not that similar, but you have to remember that you do not want a higher cost. So if you have a higher isocost, that means that it is more expensive. You don't want that. A higher isocost shifts out this way, with the graph looking like this, and you don't want that. So cost minimization input rule is the production at output levels where marginal product is equal for all inputs. And so this is the marginal product of labor over wage is equal to marginal product of capital over rental rate of capital. So you just take the L and you know that that's related to the W, put it over the W. K is related to the rental rate, put it over the rental rate. And then this is also written like marginal product of labor over marginal product of capital is equal to wage over rental rate. So that's the marginal rate of technical substitution, and those are the input prices. W over R is the input, and then marginal rate of technical substitution is MPL over MPK. So then we have optimal input substitution. So if producers increase costs more, then we use less expensive inputs. Okay, the cost function. Oh, okay. This is looking at the fixed costs, variable costs, and total costs graph. So this is the idea that fixed cost is when there's not a change in the wages, when there's a change in output. We have fixed cost in production, and variable cost is when there's a change in wage, there is a change in output, and input costs vary with output with variable costs. Total costs is equal to fixed cost plus variable costs, and so that's why graphically, if you zoom in right here, Akil, zoom into this one right here. Okay, perfect, thanks. This is a graph where total costs, variable costs, and fixed costs are on the y-axis, quantity is on the x-axis. Fixed cost is at the bottom, variable costs is below it, and so the difference between the fixed costs and 0 is the same as the difference between variable costs and total costs. And if you think back to the formula, this makes sense. This graph now makes sense because you know that total costs are fixed costs and variable costs added together. So that it makes sense that the difference between the two is the same, it's equivalent. And so in this other graph over here, we have the average total cost, average variable cost, average fixed cost, and marginal costs. And then we also have output. So this is showing us that fixed costs end up decreasing over time as you continue with your output. And that fits with what we know of economies of scale. If you're buying in bulk, then it's going to be less, like the higher output is the lower fixed costs. And the average variable costs is below the average total cost. Again, we know that this is because it's fixed cost plus average variable cost is equal to average total cost. So it makes sense that the average total cost is over there. And then finally, we have marginal cost, which intersects average total cost and average variable cost at minimum points. Another thing to note with this graph is that we should ignore sunk cost. We do not care about it. It's not something that managers that are effective should use as they shouldn't use it to make decisions. It doesn't matter. Okay, and then we have long run average cost. So we have economies of scale and diseconomies of scale. Essentially what this is it's telling us that there's multiple types of production that we can have, multiple types of output. If we need to increase, then we can shift onto a different average total cost curve, but it all is within the long run average cost. So this is just like a graph showing the different options that managers can take. And so there's diseconomies of scale and economies of scale. At economies of scale, we have declining long run average costs. At diseconomies of scale, we have rising long run average costs. And so this is another graph showing it, but instead long run average costs are below it and they're just lined up very nicely. So that is when the quantity is constant. Then we move on to chapter 8. I did skip the one about contracts, so I guess I could theoretically go over that one later. But chapter 8 talks about different market structures. So we have competitive, monopolistic, and monopolistically competitive. In perfect competition, there is zero economic profits in the long run. This is because you have many firms who are competing with each other and they drive their prices down to marginal price or marginal cost. So you don't actually have any economic profits because there's so many small firms. And another thing is that in perfect competition, everyone is a price taker. Like every company just has to take the price and they can't deviate from it because otherwise the demand will fall. In the short run, you maximize factors of production by changing the inputs. So demand is horizontal at the market price, and it is equal to price is equal to marginal revenue. Let's see if I can remember what I was talking about with these graphs. Yes, so this is profits. This little graph right here between marginal cost and average total cost is where you would find the profits. This is looking at output, and so it's looking at where the demand is equal to the price is equal to the marginal revenue, and where their profits are for a perfect competition market. This is a short run loss minimization in competitive markets. So essentially, what this looks at is the difference between average total cost and DF. And so you just that's loss minimization. A shutdown case is where it's a loss if you shut down, or the loss fixed cost is the loss if you shut down between the average total cost and the average variable costs. Between the price equilibrium and the average total cost if the loss is the shutdown case is where price exceeds average variable cost. That is for sure true. So if you ever have a case or a question where it's asking about the shutdown case for a perfect competition market, it's where price is average variable costs exceed the price or the profits that you could potentially make, and so you shut down because the costs exceeds profits. And remember, it's average variable cost, not fixed cost. It's or marginal cost is average variable. Yeah, the goal is to produce where marginal cost minus or where profits equal marginal cost minus I think that's right. Yeah, profits equal marginal cost. That would make sense, I believe, if I'm looking at this graph. Yes. And then, entering or exiting the firm looks like this. This is the market, and then this is what it looks like for a firm to enter or exit a market. Exit is on top, entering is on the bottom. So if you shift from equilibrium down, that's entering a market. If you shift from equilibrium up, that's exiting a market. And then for monopolies, the market demand curve is the monopolist's demand curve. However, their power is constrained by the demand from consumers, so they don't have infinite power. Monopolists don't have infinite power. Some sources of monopoly are economies of scale, natural monopoly, which is where it's only profitable for one firm to be in the market. Geography, import restrictions, government regulations, and exclusive control over important inputs are all things that bring monopolies to existence. So the elasticity, okay, given linear inverse demand function. Oh, that's what I was trying to note. Okay, over here is the demand function. Demand function right there. Demand function is equal to price equilibrium is equal to marginal revenue. That's what that is. I was like, DF, what is DF again? It's demand function. That makes sense. Okay, yes, back to monopolies. The elasticity of demand and total revenue. Given linear inverse demand function, Px equals alpha plus beta x. Alpha is positive, Bx is negative. The monopoly output, then marginal revenue for the quantity is equal to the alpha plus 2 beta. So the only difference there, given a linear inverse demand function, you simply multiply 2b or b the benefit quantity by 2. So simply just multiply the second value by 2, second provided value by 2, and then that's marginal revenue at a quantity for a monopolist. And so we know from the monopolist output rule that marginal revenue for the quantity of the monopolist is equal to the marginal cost for the quantity of monopolist. So that's the output of what is produced. Monopoly price is the market equal to price times quantity. So if you have a multi-plant in monopoly and they have identical production and across these plants, and so you're producing the same good across multiple plants, then consumers pay the quantity, the price at a quantity where quantity is equal to Q1 plus Q2. And then if you have multi-plant and you want to find the profit maximizing quantity, you take the marginal cost of each plant and find where it intersects with the marginal revenue and at total output. Goodness. Marginal revenue of quantity is equal to the marginal cost of one at a quantity 1. Marginal revenue of Q2 is equal to the marginal cost of Q2 times Q2. A monopolist can earn 0 profits is another thing to note. So profits continue to be good if the monopolist keeps their power, but if they lose power, then they can earn 0 profits. And so monopolistic competition is many firms, many producers, but they have slightly differentiated products, and so now advertising is very important, and differentiating your products is very different. Profit maximization for monopolistic competition is where marginal revenue equals marginal cost. In the short run, if the short run in monopolistic competition is profitable, then many firms will enter. However, if the short run is experiencing a lot of losses, then firms will exit the market. And so there are a few types of competitive advertising for advertising your slightly differentiated products. So there's again, one of them is actually differentiation. You can just change what you're offering. The other is niche marketing, so you can fill a need of a particular market segment. And then a brand myopic is the idea that some bigger brands, say take Walmart for example, they are such a name brand, they have a brand myopic. And so ultimately what they do is they don't put out new advertisements, they don't have to differentiate themselves or go through niche marketing or any of these other types of advertising. And they essentially ride the past laurels of their success. And so this decreases adaptability, and they don't put out like the optimal quantity of ads. Speaking of that, the profit maximization ratio for ads to sales is equal to ads over revenue is equal to the elasticity of for the quantity of ads over the negative elasticity quantity of revenue, looks like. Anyways, more elastic means use a lower ratio of ads. And that's all of it, I think. That last chapter was a bit of a mess.